Up to this point, you have learned the basics of Redux. Now let's take a look at a very important feature called middleware. However, the common feature of the apps made so far is that they are fully synchronous apps. In other words, when an action is dispatched, the state is updated immediately. But what if you need to get the data you need from a database or a remote server? In other words, you need to perform async operations such as database read or write and remote API calls. But where should you do this async operation? Reducer? Since the reducer must be a pure function, the reducer should not operate with side effects. If so, what about the action? Actions are like commands that contain the type of work to be done and additional data needed for the task. So it's a request to do something, not a place to solve it. The reducer was originally a place to solve the problem. Then, after the action is dispatched, the async operation must be processed before the action reaches the reducer. Redux provides something called middleware for this purpose. Let's take a look at the picture provided by the official Redux site. When an action is dispatched from the UI, the action goes to the middleware. And in the middleware, if the action is an action to be processed in the middleware, for example, if it is a remote API call, the API is called, and if not, the action is dispatched to the reducer. The reducer then computes the new state, and the result is reflected in the UI. Before we talk about middleware in earnest, let's take a look at what happens when we request data to a remote API. First, when a button in the page is clicked or the page is loaded, the app requests data from the remote API. The app then gives the user an indication that something is going on, as the data usually doesn't come immediately. Then, after some time, you may get the desired result, but for various reasons, you may not get the result. That is, errors may occur. In other words, the act of requesting data from the remote API can be divided into the moment of requesting, the moment of obtaining a result, or the moment of an error. Moments like these require changes to the app state. To do this, we need to dispatch actions that will be processed synchronously by the reducer at the three moments just mentioned. Let's see through an example. Let's create an example of getting product items from a remote API called fakestoreapi.com. The available API endpoints are listed in the resources section of fakestoreapi.com. Let's click the View Details on Docs button here. In the Products section, there are Get All Products and Get a Single Product. These two endpoints are the endpoints we will use in our app. When you get information about a single product, pass the product ID in the form of a route parameter. Let's access each endpoint directly. Let's start by typing fakestoreapi.com products into a browser window and then hitting enter. List type JSON data is displayed. This endpoint returns 20 products data. The reason the JSON data is displayed so nicely on the screen is because I'm using the Chrome extension JSON Viewer. Next, enter fakestoreapi.com/product/1 into the browser address bar and hit enter. Object type JSON data is displayed. We'll use this data to create a product model later. Now let's look at the series of processes of handling async code through middleware by implementing the code to request the product list from fakestoreapi.com. As I just mentioned, there are two critical moments when you call an API that takes products. The first is the moment the API call starts. The second is the moment the API call is completed. There are two cases of completion. The first is the moment when data is successfully received, and the second is the moment when the data is not received successfully. These moments require a change in the app state. To do so, we need to dispatch normal actions that will be processed synchronously by the reducer. As I said, remote API calls require dispatching at least three different actions. First, an action that tells the reducer that the request has been triggered. When the reducer receives this action, it changes the status of the state or Boolean flag. When managing with the status, I usually create and manage enums. Considering the situation of fetching product data, there may be the following statuses: before product data request, product data request, product request successful, product request failed. Each status can be expressed as enum data, such as initial, loading, success, and failure. When managing with Boolean data, create the variable such as isFetching and set isFetching to true if it is being requested, otherwise set isFetching to false. I prefer to use enums over using Boolean flags. The reason I prefer enums is that the code is more readable and each status is mutually exclusive and exhaustive. For example, when a request starts, change the initial status to loading status. Then the UI shows to the user through a spinner that data is being fetched from the remote API in accordance with this status change. Second, an action that tells the reducer that the request was successful. When the reducer receives this action, in addition to changing the status of the state, the data received from the API is reflected in the state. In this case, the reducer changes product status from product status.loading to product status.success. The UI no longer shows the spinner, it shows the data fetched from the remote API. Third, an action that tells the reducer that the request failed. When the reducer receives this action, in addition to changing the status of state, the cause of the error is reflected in the state. In this case, the reducer changes product status from product status.loading to product status.failure. The UI no longer shows the spinner and shows the user the cause of the error. The actions mentioned before can be expressed in the form of the following code. The state shape reflecting the process of retrieving data from the remote API is as shown in the figure. F-state consists of an enum of a product status type, product to store data when the request is successful, and an error to store errors when an error occurs. To improve the code readability, we create a factory constructor called fstate.initial. Create the copied function for immutable state update. Next, let's look at a reducer that computes the product list related state. If the action is a fetch product action, use the copied function of the state to create a new state whose product status is a product status.loading and return it. If the action is a fetch product succeeded action, then data has been successfully fetched from the remote API. In this case, use the copied function of the state to create a new state where product status is product status.success and product is action.product and return it. If action is a fetch product failed action, then data fetched from remote API has failed. In this case, use the copied function of the state to create a new state where product status is product status.failure and error is action.error and return it. If there is no such action, the state is returned as it is. Okay, now we have a reducer that handles the action, but where are actions like fetch product succeeded action and fetch product failed action triggered? Should the user trigger it? No. The middleware mentioned earlier triggers it. Middleware is a function that is executed before dispatched actions reach the reducer. Middleware listens for actions and performs tasks such as async calls when it receives an action it needs to process. In our example, this would be fetch product action. Dispatch fetch product succeeded action when data is successfully received from remote API, and fetch product failed action when it fails. Let's take a detailed look at the middleware function through the pseudocode. The middleware function takes 3 arguments. The first is the store. You can access the state through the store's state getter and dispatch actions using the store's dispatch function. The second is the dispatched action. Middleware checks the type of action and processes the action it needs to handle. What to do if it is not an action to be dealt with. If you have multiple middleware, you should send the action to the next middleware or to the reducer if not. That's why we need the ability to send the action to the next middleware or reducer. That is the third argument, the next function. Middleware can also swallow actions. That is, it terminates the action without forwarding it. If our middleware encounters a fetch product action, called fetchProduct function of the API instance. If successful, dispatch a fetchProduct succeeded action instance with products as an argument. Then the reducer updates the state using the product received from the API. When an error occurs, dispatch an instance of fetchProduct's failed action with the error as an argument. Then the reducer updates the state using the error. If the action is not fetchProduct action, immediately use the next function to forward to the next middleware or reducer. And if the action is a fetchProduct action, make an API call. The fetchProduct action is passed as an argument to the next function before the fetchProduct call ends. In the next chapter, we will create an app using real middleware.